So I always tell people that this primary time when you're transitioning from high school to college is the most vital time, not of your life, but of your future career. And the reason why I personally say that is because a lot of us in the room are first generation students. We're first generation college graduates or soon to be college graduates. And one thing that I really wish that I had more of was mentorship. I want all of the students here today to know and understand that each and every single one of the speakers today are here to serve as your future mentors. You have a pool of MIT graduates and doctors and nurses and entrepreneurs and lawyers and those in the legal field. This is truly the best pool of people that you can look for because these are people who want to help and who want to guide you, which is why the person that is leading our first discussion is going to be Dr. Maha AlHusseini. Dr. Maha AlHusseini completed medical school, her residency in internal medicine, and fellowship in endocrinology at Wayne State University School of Medicine. In addition to treating their medical problems, Dr. AlHusseini believes in empowering her patients and the community with the tools to help them achieve their most optimal health potential. She currently works in private practice in Dearborn, Michigan, and is a pivotal leader in making today's event happen.
Assalamu alaikum. Good morning, everyone. Is everyone awake? So I get to go first, so I can wake everybody up, hopefully. I want to thank all of you for taking your precious time out of your weekend and coming and attending this workshop on a Saturday morning. I can guarantee you that you guys are all on the journey to success by being here today. I know that you guys are all smart because you made the decision to be here today. But what I would like to do is I would like to share with you some tips and some information on how you can become even smarter so that you could reach your fullest potential in your future. The title of my presentation is How Taking Care of Our Bodies Can Help Us Develop Smarter Brains. The first thing I'm going to do is I'm going to share with you some information on how the brain actually functions. Because if we can understand how the brain functions, we can actually take that to our advantage. As you can see from this picture, the brain is made into different regions, and these regions are not separated, they all work together. At the very end of the brain, there is the brainstem, and the function of the brainstem is actually necessary for survival. So things like breathing is actually controlled by our brainstem. If something happens to our brainstem, you could only imagine what could happen to us. Right above the brainstem is the cerebellum. The cerebellum's main function is in balance and coordination. So me standing here today is actually being controlled by my cerebellum because without that, I can't stand upright. Above that, there's the occipital lobe. The occipital lobe's main function is, one of its main functions is vision. So all these beautiful images that we see, they're all made possible by the occipital lobe. Above that, there is the parietal lobe. The parietal lobe has so many functions, including movement, things like reading, writing. All of these things are controlled by the parietal lobe. The movement of our upper body, lower body, all of it is controlled by the parietal lobe. And then right here on the sides, by our temple bones, there's the temporal lobe. One of the main functions of the temporal lobe is actually speech. And in the temporal lobe, there's a very important region called the hippocampus. How many people have heard of the hippocampus? The hippocampus's main function is actually storing memories. So if you want to have a strong memory, you want a strong functioning hippocampus. Likewise, there's another very important region by the hippocampus. It's called the amygdala. How many guys have in here have heard of the amygdala? The amygdala is the emotional center of the brain. So this is where our emotions are actually generated. So things like fear and anxiety and excitement, all of these emotions are generated in the amygdala. And you may have heard of the saying that memories that leave a strong impact or strong emotional impact on us tend to be remembered longer. The reason for that is because of this very close proximity between the hippocampus, which stores memory, and the amygdala, which generates emotions. And we must not forget the very last lobe, which is right here in the front, and it's called the frontal lobe. The frontal lobe serves also many functions, one of them being problem solving, another one being judgment, even things like our personality, decision making. All of these things are dictated by the frontal lobe. So you could only imagine what would happen if something actually happens to someone's frontal lobe. As you guys know from biology, all organs are made of what? Cells. And the brain is no different. The brain is made of cells. The brain cells have a special name. They're called neurons. Every cell in the body, or almost every cell in the body, has a nucleus. You guys see where it says the cell body? So this is the cell body. And right by the cell body, there's these dendrites. They're like tentacles. What they do is they receive information. And then this information is then sent down this path called an axon, also called the myelin sheath, and it's pretty much made of protein and fat, as simple as that. So once the information is received by these dendrites, it gets passed down this axon, and it finally reaches the axon terminal. And at the axon terminal, it gets transferred to the next cell. This is actually how information is transferred in our brain. And this is how we know what we know. It's through cells functioning in this pattern. If we look at the junction between one cell passing information to the next cell, this is what it looks like under the microscope. So basically, this information that I'm talking about, it comes in the form of chemical messengers that are then transferred to the next cell, and this is how information is passed down. Now, these chemical messengers, specifically in the brain, they're called neurotransmitters. They are basically protein. That's what they're made of. Inside the brain, this is what it looks like. It's a lot of connections. These connections, their scientific name is synapses. And the stronger these synapses are, the more functional our brain is. So if we want to grow smarter, we need to have strong and healthy connections. So how do we grow healthy and strong connections in the brain? Well, before I get there, I have a true or false question. By the age of 12, your brain has reached full development. How many people would say, true, the brain has fully developed by the age of 12 or by the time we're teenagers? How many people say the brain is fully developed? Raise your hand. How many people say the brain has not developed by the time we're teenagers? Okay, so most people know this already. Great. It turns out that, yes, this information is false. The brain is not fully developed by the time we're teenagers. The brain develops very rapidly in the first 3 to 5 years of life. And by the age of 9, actually, most of the brain regions that I showed earlier, they are actually developed. However, the brain does not reach full development. Some people say the age of 24, some people say late 20s. So what we know is that the brain does not reach full development until later into our 20s. So if you look at this diagram right here, The green color indicates brain regions that have not fully developed yet, and blue indicates full development. So by the age of 5, we still have a lot of areas in the brain that are not fully developed, and this process continues slowly into our 20s. Now, what part of the brain develops last, according to this image? Where do you see now the most blue? Into our 20s, yes, but what part of the region took the longest to develop? So actually, this right here is the front of the brain, and this right here is the back. So what takes the longest to develop is the frontal part of the brain. The frontal lobe. You guys remember what the frontal lobe's function was? Making judgments. What else? Making decisions, personality. So all of these things are still in development until into our 20s. And that is why, because the brain is not fully developed in our teenage years, it's really a window of opportunity. What do I mean by that? There is a saying in medicine that says connections that fire together, wire together. So if we instill good habits while still our brain is developing, it is these habits that are going to carry through into our adult lives. So, for example, if I train myself when I'm a teenager to eat healthy, I'm likely going to continue to eat healthy as an adult. If I train myself to engage in healthy habits like exercising when I'm a teenager, this will likely continue to happen as an adult. Even things like the way we think. If we train ourselves to think positively when we are still growing up, we are likely to continue to think positively as adults. And the same applies for negative habits, right? So if I engage in unhealthy habits as a teenager, I have a higher likelihood of continuing those negative habits into my adult life because the brain at that point is not still fully developed, and those connections are getting stronger and stronger. So the question that I asked earlier about how do I maintain these healthy connections and healthy brain cells? What is the main source for energy for the brain? The number one source of energy is actually glucose. Glucose is the main source of energy for the brain. Glucose, as you know, is sugar. Now, the body needs sugar, specifically the brain needs sugar, but at the same time, too much sugar is harmful to the brain, and I'll go into that in a minute. So we need glucose. You guys remember I mentioned when information is passed down this axon, what is that axon made of? Protein and fat. So the brain actually needs protein and fat. So we need a healthy nutrition that combines all these three nutrients. And remember I mentioned that these are chemical messengers. So there's a chemical reaction happening here. This chemical reaction requires minerals and vitamins. Where do minerals and vitamins come from? Nutrients, specifically fruits and vegetables. Okay, so I have some news for those who don't like fruits and vegetables. If you don't eat an adequate amount of fruits and vegetables, you're actually not getting a good signal transferring between your brain cells. So I urge you from now to become friends with fruits and vegetables. The brain is made of 75% water, so we need good hydration for good brain function. And I had mentioned that too much sugar is harmful for the body because it can actually slow down the brain. So we do want glucose. We don't want to eliminate it altogether from our diets, but in too much quantity, it will slow down the brain. It will increase inflammation in a specific area in the brain, the hippocampus. Remember the hippocampus? What's the function of the hippocampus? Memory. Memory. So too much sugar actually affects the brain region that's involved in memory. And also, too much sugar will lead to an instability in these chemicals. So people who eat too much sugar can actually develop things like mood fluctuations, and even they're at high risk of depression and anxiety. So this is what a balanced meal should look like on this side. Okay, if you look at this plate, half of our plate should be made of vegetables, and then a quarter of it should be made of protein. Okay, and then another quarter should be made of starches. Glucose comes from starches. So this would be an example. This plate right there is an example of what a healthy, fully nutritious meal looks like. On the other hand, on this side, this would be a sugar overloaded meal, too much sugar, too much fat, and most importantly, it's processed, right? None of what you see in that meal is actually real. It's all processed food. So this is something that would not help you develop strong brain connections. Excuse me. How about exercise? Do you think that when you exercise your body, does that have any effect on your brain? Do you think there's a relationship? Yes, there is a relationship between exercise of the body and brain development. So when you exercise, your heart is pumping. There's more blood flow. Where's that blood flow going? To the brain. And with that blood flow going to the brain, you have transfer of nutrients. Nutrients are reaching the brain and toxins are being removed from the brain. So you could see how would that, you think you're exercising your body, but actually you're developing a healthier brain when you do that. Exercise has been shown to increase memory. So there's an effect on exercise and memory. And then exercise also decreases our stress response. You know, when you exercise, there are chemicals that are being released, and these chemicals actually are called happy chemicals. They make us happier. So exercise is good for mental health. Okay, many people, when it comes to mental health, they jump to medications and things of that nature, and those are necessary sometimes. However, by exercising, we can actually boost those happy hormones and happy chemicals. Do you think sleep has an effect on the brain? Yes. Okay. So when we're actually sleeping, the brain does not shut down. The brain is very active when we are sleeping. Sleeping removes toxic products. So there's a recycling process that happens when we're sleeping. And sleeping solidifies memory. So for example, let's say you have an exam and you go study for that exam and you go to sleep. Guess what? When you're sleeping, you're actually helping your brain remember what you studied for the next morning's exam. So don't miss out on a good night's sleep before your exam. Let's talk about some harmful substances that can affect the brain. Nowadays, many people are using marijuana, unfortunately. The active chemical ingredient in marijuana is THC, and it can act on different regions of the brain. One of the main regions that it can act on is on the hippocampus. And what does that do? So people who use marijuana, specifically teenagers, because their brain has not fully developed yet, can actually have problems with their memory. And THC can also act on another region in the brain called the amygdala. You guys remember the amygdala? What did it do? It's the emotional center of the brain. So people, specifically teenagers who use marijuana, can actually have a higher response to fear and anxiety and mood fluctuations. They actually did a study on teenagers who used marijuana, and they saw what happened to them as adults. And they compared them to teenagers who never used marijuana. And they noticed that teenagers who did use marijuana had an IQ score that was lower by 8 points. So unfortunately, chemicals like these can make the brain less smart. And we actually have data that shows this. So they were less smart by an IQ score that's lower by 8 points. In addition to that, they were less likely to graduate from college, and they had less scores in college. Nicotine, where does nicotine come from? Comes from smoking, right? From cigarettes, from vaping. And nicotine also has an effect on the brain. It can change the mood, it can change our attention span, it can decrease our learning. E-cigarettes brand themselves as something that doesn't contain nicotine, but it turns out that 99% of e-cigarettes actually has nicotine in them. In addition to that, there's all these other harmful substances that most of us can't even pronounce what they are. And all of these things have been shown to be in e-cigarettes, and guess what? All of these things are a poison to the brain. Hookah. Do you think there is any harmful substances in hookah? Yes, it does. There's about 82 toxic chemicals and chemicals that can cause cancer in hookah. And specifically, when the charcoal burns, this increases carbon monoxide. And carbon monoxide is also a poison to the body and to the brain. Something that's very popular nowadays is energy drinks. A lot of people are drinking energy drinks. Now, not all energy drinks are the same. That's why you really have to be reading the food label and seeing exactly what you're consuming. But many energy drinks have a lot of caffeine in them, they have a lot of sugar, and they have other chemicals that stimulate the brain. And these chemicals, when they're consumed in a high amount, they can increase the heart rate, which can increase the blood pressure. And some people, as a result of that high blood pressure, they can actually get a bleed, so they can get a stroke in their brain. And I showed you in the beginning that all these different brain regions have different functions. So if someone has a brain bleed in a specific area of the brain, they will lose the function that's in that brain region. Even things like heart attacks, seizures have been shown happening in people who consume a big amount of energy drinks. Headaches, panic attacks, insomnia, lack of sleep, lack of attention. All of these things can happen in people who drink energy drinks. Electronics. Do you think electronics has an effect on the brain? So they did this study where they took a group of teenagers and they had them watch video games for 2 weeks, and they compared them to teenagers who did not watch video games. Now, just to be fair, the video games that they were watching, they were violent video games, okay? And if you look at this picture, the color orange indicates brain activity. Look what happened just after 2 weeks of watching video games. There's less orange color, right? So meaning there was less brain activity in certain regions of the brain. So some people actually lost some brain cells in that process. And this is only after 2 weeks of watching video games. Do you think social media has an effect on the developing brain? Again, they did a study where they looked at the brains of teenagers that were using social media frequently, and they saw that there are certain regions in the brain that actually light up when someone, specifically a teenager, is using social media. And when they followed these teenagers, they found them to be more sensitive to criticism, so they were not taking what other people are telling them lightly, and they also had higher rates of depression and anxiety. What are other ways to become smarter or to develop smarter brains? When you read, you learn new information. When you learn new information, guess what? You're building new connections, new synapses. When you learn new skills, anytime you learn a new skill, you've actually either strengthened an old connection or you just built a new connection. When you travel, you actually become smarter because traveling is considered acquiring a new experience. When you join service projects, community projects, all of these things actually have a positive effect on brain function. And then finally, having a good social support system, such as having good friends and having strong bonds with your family, all of these things have shown to have a positive effect on the brain. So, in summary, how can we become smarter people or develop smarter brains? Number one is eat nutritious meals that include a healthy source of glucose, protein, and fat. Exercise has an effect on the body and the brain. Sleep, as I mentioned, removes toxins and solidifies our memory. We need to avoid toxins such as smoking, vaping, drugs, energy drinks, using too much electronics and too much social media. We need to avoid that. Working on gaining new experiences, and finally having a healthy and strong social support system. So don't underestimate those friendships that you make with the good people in your lives, with your family members, with your extended family members. All of these things are healthy for the brain and make us smarter people in the future. So this is my presentation for the physical aspect of today's presentation. I hope that you guys will implement some of the things that I mentioned. And like Ren mentioned earlier, we will leave the questions for the Q&A session when we do the panel discussion. And with that, Ren, I call upon you. Thank you.